We're asked to find what force is required to keep this machine in equilibrium whenever this input force of 100 newtons is applied. And to do this, we're going to find this force of BD, and find its x component, which will apply a force in this direction. And if we can find this force, then we know what force is required to keep it in equilibrium, since it's just going to be equal to whatever this force is, this x component of the force. And to do this, we're going to first start by finding some unknowns in this figure, since we can use the expression that the sum of all moments about the point C is equal to 0, since it's going to be in equilibrium. So I'm going to first find the length from C to G. And to do that, we can write the length from C to G is equal to 200 times the cosine of the angle beta. And next we're going to find the length from E to D. So to find the length from E to D, we can write that as 200 times the sine of beta minus 35. Right, because we need to get rid of this 35 here. Since we're taking the sine of this from B to G, we're finding the length from B to G and then subtracting this 35. And next we can solve for the angle theta. We can solve for this angle theta. And we can write it as theta is equal to the sine inverse of 200 times the sine of 20 degrees minus 35 divided by 250. And this will give us an angle theta of 7.68 degrees. And we now have everything we need to use this expression. Sum of all moments about C is equal to 0. So sum of all moments of C is equal to 0. And we can write that as the force BD times the sine of 7.68 times 200 times the cosine of 20, and then minus force BD times the cosine of 7.68 times 200 times the sine of 20, and then plus 100 times the cosine of 20 times 350. Set that equal to 0. And we can take this expression and solve for the one unknown variable. We're trying to solve for this force. It's right here and right here. So we solve for this unknown variable and we do the rest of the calculations. So solving for that, we'll end up with a force BD that is equal to 770.6 newtons. And we now try to find the x component of this force, because remember, this x component will give the applied force to the right, and that will be equal to the force required to keep the machine in equilibrium. So to find this x component, so the x component of F is going to be equal to the force we just calculated times the cosine of 7.68. And this will give us a force of 763.69 newtons. And this will be in the right direction. And since we're trying to keep the machine in equilibrium, we can say that this is also equal to the force Q required to keep it in equilibrium.